Well, here it is, the Bambu Lab H2C. This is maximum Bambu Lab. One fixed hotend, 6 quick swappable ones in a presentation that is so over the top for a 3D printer, I don't know if I'm looking at a machine or an art piece straight from Cyberpunk. The big promise of the 6 hotend vortex system is that this is Bambu's solution to wasteful multicolor and multi-material printing that you typically get when you use their AMS as a filament multiplexer. There are so many smart details in this thing that have a lot of implications in day-to-day use, so I do want to focus on the tool changing or hotend changing setup for this video. You can check out my impressions of the general Bambu H2 platform in my H2S review, it is sitting back there, which I'll link at the end. For this video, I want to go over the technical details of the Vortex hotend changer system, compare its speed, efficiency, and performance to a traditional Bambu AMS experience, and I do want to see how it stacks up against the currently reigning champion of multi-material printing, the 5-tool Prusa XL. And while that has an effective particle filter in its enclosure air exhaust, the H2 series does not, and that's a correction that I need to make real quick versus my H2S review, because there, and on this H2C of course as well, the air filter is completely out of the equation when the printer runs in cooling mode for low temperature filaments. Over the years, I've developed a sensitivity to the particle emissions from PLA, and the P2S did give me an incredibly scratchy throat. I hadn't noticed it with the H2S because I was mostly printing PTG with it, but thankfully the H2 series does have a clearly defined exhaust path, so it makes it really easy to use aftermarket solutions like the Vento from today's sponsor, Voxel PLA. The Vento mounts over the H2 series exhaust flaps and keeps the printer's functionality fully intact. It's built with the same filter technology as Voxel PLA's X filter, combining an EPA 12 filter to capture particles and an activated carbon cartridge to reduce VOCs and odors. Because it sits directly in the printer's exhaust air path, it works even when the printer disengages its internal filter element. Honestly, I think that's a pretty essential upgrade for any of the H2 printers. Voxel PLA of course make fantastically reliable PLA and PTG filaments. That's what I've been feeding the H2C for all the prints in this video. For this holiday season, Voxel PLA are offering an extra 10% off every order over $100 with the coupon code HOLIDAYJOY10. And do make sure to check out their bulk discounts on filaments at the link below. There is obviously more than one way to solve the tool changing conundrum. You can reduce the fixed tool head to just a carriage like on the Prusa XL. You can try to keep as many of the repeating parts on the fixed tool head and just change the parts that are involved in the filament handling, so the hotend and extruder like on the SnapMaker U1, or you can change just the absolute minimum amount of components like on the Bondtech INDX, and keep as much as possible on the fixed tool head. The Bambu Vortex system is pretty close to that solution. The only thing that you are changing is the hotend itself and its temperature sensor. That is handled by a small sub-processor that is fixed to the hotend and communicates with the toolhead through this small transmission coil in the corner here. But unlike the Bondtech system, the filament does not stay loaded in the hotend when it is parked. Instead, the Bambu H2C cuts the filament before every change and uses the same Teflon tube going to the toolhead to feed the right material for each hotend through an AMS. So for every hotend change, the H2C cuts the filament, the AMS starts retracting the filament, and while that is happening, the printer is parking the hotend, picks up the new one, and the AMS feeds the correct filament for that nozzle back in. This is a pretty cool reuse of components, as Bambu is shipping the AMS with almost every printer already, and it's one of the most tested and best established technologies that they have. And it actually works out pretty well. You need to preheat the new hotend anyway, so that extra time that retracting and refeeding the filament takes doesn't really add on to the print time, but we'll benchmark that in a second. The hotend gets heated inductively with this massive claw that reaches around the melt zone of each hotend when it's inserted in the toolhead. This is basically a powerful transformer that couples into an iron core on the hotend itself. Now, it's pretty similar technology to an induction stove or actually a wireless phone charger. But unlike the Bondtech INDX system, the Bambu Vortex hotends still have quite a bit of thermal mass, which means they do take some time to heat up. Bambu says the heat up time is just 8 seconds, which I can confirm, but those 8 seconds are just one of many things that need to happen for a full nozzle change. The storage rack for the Hotends is where I think things start going a bit over the top. Any other manufacturer is just going to use a plain parking attachment, and then, they're going to have some sort of an active locking mechanism on the toolhead. But Bambu is going a step further, because their loading geometry accepts the Hotend from the front. They would only be able to fit 3 Hotends into a static parking rack, if it was just fixed to the side of the printer like this. So to work around that, they built this 2-story motorized rack that has 2 banks of Hotend parking positions and actually uses the BLDC servo motor from the extruder to move the rack up and down to, present the right Hotends and to assist in inserting the Hotend into the toolhead. There is also a little pin in the back of this rack that the toolhead parks itself over and then yanks itself to the side to either lock or release the Hotend with this locking fork. You do get a spare. So, because the Bambu H2C is cutting the filament for every Hotend change, this platform has its own unique set of strengths and weaknesses. First off, it does mean that each Hotend is not strictly tied to one specific filament. So, as long as you have the filament you want to use loaded in one of the AMSs that is connected to the tool changer side of the H2C's toolhead, you will never have to manually swap filaments and load them into the right Hotend before you print. That's a major annoyance on the XL. So let's say you have a full set of PLA and PTG colors loaded up in a couple of AMS boxes that are all tied to the right side of the toolhead, so the Hotend changer side. You just select any of those filaments in the slicer, and it will assign it to as many available Hotends as your printer has. So in my case, they shipped the printer with 4.4 Hotends, 1.2 Hotend, and 1.6 Hotend. So I can use any 4 filaments that this toolhead has available through the AMSs, and it will work in its most efficient tool changer mode. Any more than that, and you will either need to use the left Hotend as well, which is, the fixed one, or accept the downside of having to purge out one of the Hotends in traditional AMS style multimaterial printing. You can combine those as well. The slicer will automatically suggest what it thinks is the best combination of filaments loaded into each of the AMS boxes you have attached to each of the toolhead sides. I think it takes into account, the transition between different colors and which ones work best together. So you can choose between convenience and running some of the nozzles in the AMS purging mode, or efficiency, which means you might need to manually swap a couple filaments around between the left and right nozzle AMS boxes before the print. But of course, you can also just manually assign each material to a specific nozzle or toolhead side. It's rather complicated, but once you use it and figure it out, it's not that bad. It's pretty intuitive once you get the hang of it. You can also choose which nozzle size you would like to use, and the printer is going to pick up the correct one. But as of right now, mixing nozzle sizes in the same print is not supported yet. So with this vase that I printed using the 0.6 nozzle in PTG, I couldn't use the PLA support material for the bit of support on the inside because I don't have a second 0.6 nozzle, either on the fixed or the tool changer side of the printer. On the Vortex system, the Hotends identify themselves to the printer with their serial number and their nozzle size through that wireless transfer coil. So you can't trick the machine into, say, using a 0.4 like it was a 0.6 if you just need a second, matching nozzle. Because the H2C cuts the filament on every Hotend swap and does not have a nozzle blocker flap on the Hotend parking positions like the Prusa XL has for its toolheads, you do lose out a bit of filament in the process of it sort of oozing out and going places it's not supposed to be while it is parked. And, they then have to be reprimed after they've been picked up. This is not a massive difference in material use though versus a full tool changer, and it's still way better than purging out a single Hotend every time with an AMS. You can choose to purge less with the nozzle swap as well, though that comes with the risk of the Hotends not being completely filled when it then starts printing again. And because the filament has been cut, it needs to push out that cut bit into the melt zone, or otherwise it won't be able to retract the filament for that first bit of the fresh extrusion. But Bambu also retained that second nozzle from the H2D, which they really didn't have to, since you now have 6 different nozzles on tap and basically as many filaments as you want. But the second nozzle does cut out that swap time and preheating time. And since on the tool head itself, there is that little blocker flap that physically stops the other nozzle from oozing, if you stick with just 2 filaments, you get basically instant switch over between the two, just like on the H2D. No nozzle parking, no waiting for the preheating, and no filament retraction into the AMS. This is, of course, the fastest mode of printing, and judging by how I'm using my Prusa XL, it's the one mode that is the most appealing to me. Specifically, it's for printing that dissimilar support material like PLA underneath a higher performance functional part. Being able to easily and efficiently do that has been a game changer for me in the way how I design parts and how complex those parts can be before they become unprintable, or in the case of using a filament multiplexer, become just unreasonably expensive. But even in that use case, the H2C adds easily accessible nozzle size changes that you can mix and match with any of the filaments on tap. One feature that Bambu is also implementing is that you can permanently reserve one of the induction nozzles to one specific filament type. I don't know how much of a real effect that is, but for some filaments there is supposed to be a seasoning effect with the nozzle, where that nozzle will work best if you only ever use it with that specific filament type. So if you set one of the induction nozzles exclusively for example, PPSCF, Bambu Studio will automatically block that nozzle for all other filaments and only use it when you're printing with PPSCF. And this is actually stored in the processor on the Hotend itself, so that info will stick with it if you move it to a different slot or even a different printer. So how well does it work? Well, this is where it gets kind of spicy. So yes, basic printing works flawlessly. We've already seen that on the H2S. Print quality is great. And I think the user experience on the printer itself and in the slicer is very well done, extremely well integrated. And for a product that isn't even out yet, at least at the time when I'm testing this and writing this review, I've not had any issues with functionality not working as intended or just not being there yet. The tool changing process works great. It has never dropped a tool or failed to swap a tool for me. The AMS did retract the filament a bit too aggressively once and ended up snagging it, which it caught and paused and waited for me to fix it, and then the print moved on like nothing ever happened. It also detected filament blobbing once on the Hotend through one of its many cameras, when there was clearly no blobbing happening. This was on the bar and owl print, and just like with the AMS issue, it paused and waited for me to fix the issue instead of just failing the print. Now there is a bit of a layer line on the print, but after turning down the sensitivity, that hasn't happened again. And of course I did want to see what the multi-material printing experience was like. Prusa had just posted about their multi-material torture test, the bench bin, which is a 4-material print. So I decided to give that a shot on the H2S in full AMS multiplexer mode, on the H2C, both using the fixed Hotend plus 3 Vortex Hotends, and using just the Vortex Hotend swapper with all 4 Hotends being changed. And of course I'm also including the Prusa XL itself, which only does tool changer mode, but I printed it with and without the prime tower. I also did a single color reference on each of the platforms just to give us a baseline speed. I printed these at 50% scale because honestly the material use would have been obscene if I went with the regular 100% scale. This part has all 4 colors on almost every layer, and as such it already is a challenging print at the original size, so printing it at 50% does not come with the expectations of the parts coming out great. But we can still look at which printer is the least bad at printing it. And you know what? They all did okay. The lid came loose on the H2C ones and on the XL ones, but overall the multicolor print from the H2S actually looks the best and the cleanest. Not surprisingly, it was also by far the slowest. In just the time that it took the H2S with its single nozzle and an AMS to print one of the bench bins, the H2C managed to print both versions of the multi-material test and the single material print. 3 parts in the time that it took the H2S to do 1. But the XL did the same thing again. In the time that the H2C completed its first multi-material print, the XL had already done both its multi-material prints and the single material one. I did not expect this. I mean, the XL is what, a 3-year-old platform now, and it beats the just released H2C? I mean, sure, the XL has always felt more like a tech demo than an actual finished product, and absolutely, it is way behind when it comes to the overall user experience and just polish. It is much more of a quirky, nerdy product, but when it comes to just the core functionality of spitting out parts with up to 5 materials, it still is the undisputed champion. And not just in speed, but also in material use, but there is much less of a difference between the amount of material used from the XL and the H2C. And having these two printers now, just doing multi-material printing with a single hotend and a multiplexer, where it needs to flush out the whole hotend every time it does a change, looks even more ridiculous now. When doing batch printing, where you fill up the entire bed with parts, it might not be that much of an issue, but for reference, here's the overview of how much extra material and print time each of the approaches demand every time you do a filament swap. And this is an average for this print. It already accounts for the fact that you can finish one layer with the same material that you start the next one with, so you save one filament swap there. And because yes, this bench bin is a bit of an extreme case, here are some numbers from the slicer for a more realistic part, one of the joint halves from Carolyn. While the Bambu Vortex system is not the highest performance multi-material setup you could think of, it excels in being incredibly flexible in day-to-day use and brings down cost of the machine, of the setup, versus building a full toolhead with its own extruder for every material you want to load into the machine. As far as I know, this is the first Hotend changer 3D printer that's available at volume, so some kinks are to be expected. To reduce the switchover time between each induction nozzle, Bambu are recommending to use a Teflon tube that is as short as possible between the AMS and the printer inlet itself. I already used the shortest tube I could, and the limiting factor now is the heat up time of the nozzle of the hotend and its stabilization time. Maybe in the future we'd see extra heaters in the parking position that can at least slowly preheat the hotend before it's even picked up, and that would cut down on these switchover times pretty drastically. But that of course is going to drive up the machine's complexity and cost. What's more important to me right now is that the core of the system works reliably, and as always, speed comes after everything else. The Bambu Vortex system is designed in a way where you can upgrade an H2D or an H2S to an H2C with the hotend changer. With the Vortex induction hotends having their own microcontrollers essentially, one of the things I asked Bambu about was whether this was going to be sort of a DRM or vendor lockout mechanism that is being introduced with the H2C. Because so far, while the Bambu hotends were proprietary, anyone could build one that was compatible with the mount, print the identification dots on it, and the printer would read the nozzle diameter and hotend type just like it was an original hotend and use it, no issues at all. For the Vortex induction hotends, the answer I got was that third-party hotends were not supported in the interest of user safety for concerns around the thermal runaway protection working as intended with non-genuine hotends. Which, yeah, I mean that makes sense. I'm sure that the inductive heater could literally turn the hotend into a molten blob of metal in less than a minute. But to me, that statement implies that the electronics on the induction hotends do have some sort of DRM built in, kind of like printer ink cartridges. You can, of course, get spare induction hotends from Bambu in all the sizes up to 0.8 and as high flow versions as well. But you can't just swap out the nozzle itself on the hotend, you have to replace the whole thing. Heatsink, electronics and all. And each spare induction hotend comes in at about $20 extra compared to the equivalent fixed hotend. So $39 for a standard hardened one and $59 for a high flow hotend. Now, comparing the Prusa XL to the H2C might be a bit of an apples to oranges matchup, but there is a consistent difference in design principles that shows itself pretty clearly in the hotend mounting clamping mechanism. On the Prusa XL, there are 2 over-center locking bars that engage with a pair of pins on the toolhead that is running on ball bearings just to make sure that every metal-on-metal contact is a rolling mate that is not going to wear out like it was just steel rubbing on steel. Bambu, on the other hand, are doing exactly that. They've got this fork that just rubs on the hotend. There's a bit of lube on there, but that's not going to do much in the long term. They just accept that this is a part that will eventually wear out, and they give you a replacement for when you eventually need one. The same for things like the filament cutting mechanism in the toolhead or the nozzle wipers on the poop chute. Those are just considered consumables, and you just replace them once they stop working well. Prusa pride themselves in making printers that require very little maintenance, but unless printer downtime minimization is your top priority, it might actually be cheaper and actually more resourceful to not overbuild a part and just use a version that is, cheap to manufacture and easy to replace, like Bambu does with their printer parts, and you might argue even with their printers themselves as a whole. So, is it cheap? Well, it's actually closer to an H2D than a Prusa XL. What I appreciate is that the tool changer system does not introduce any downsides versus a regular H2D. It is a straight upgrade in every regard. That's why they kept that dual Hotend toolhead. If you use just the tools that are loaded in the head, you skip the entire Hotend swap time and you get the exact same print time, performance, experience as with an H2D. And compared to using, true AMS as a filament multiplexer with a single nozzle, their Hotend swapping approach in the H2C does manage to bring that speed penalty and especially the amount of purge material required way down, and it's at a level where I think it's totally reasonable. So using the multi-material feature is not that much of a trade-off anymore. Compared to the Prusa XL, the H2C still has a much larger print speed penalty the more materials you add, but I can tolerate a longer print time much more than I can wasted filament for multiplexers. And for stuff like I do, which is mostly one extra material for support, it's not that much of a print time difference. But then I could also just use an H2D as well. The H2C is definitely the most convenient multi-material setup there is. I was trying to work in like some sort of car comparison joke here, but that would just end up offending too many people. The fact that they're combining filament selection from the AMSs with freely being able to choose any of the Induction Hotends loaded up with any of the filaments in there just makes using a different nozzle size or combining different filament colors or materials incredibly effortless. You select it in your slicer and the printer does the rest for you. That is incredibly well done on this platform, and I always like it when there is more choice for you as the consumer to choose the product that is the best fit for your specific use case. I mean, I could deal with a bit less showmanship. But that's just how Bambu rolls. If you want to roll with them, you can find the links to the H2C in the description below. And that marks the end of my 2025 Bambu review-a-thon. I did have some non-Bambu content planned between the P2S review and this one, but then I caught COVID, and that not only wiped me out for a couple of weeks, but also wiped a bunch of videos off my schedule. But as always, thank you for watching, take care of yourselves, and I'll see you all in the next one.